When ChatGPT first came out, it made a massive impact. In many ways, it continues to make that impact. Some of my own research studies show that more than 30% of people out there haven't used any sort of AI tools just yet. But strangely enough, the way we interact with ChatGPT is really not very new. I mean, it's not like it's a droid that follows you around or some sort of really interesting hardware device. The interface that OpenAI developed is not particularly interesting from a design perspective. It's really just kind of a traditional chat interface. So that type of interface has been around forever, and some of your users might not really be impressed by it. So when it first launched, a lot of my colleagues asked me, well, don't we have a chatbot already? Why do we need ChatGPT or OpenAI? And that's a fair question because users just can't always differentiate what's going on under the hood. So here's a couple ways that you can help answer that question, and you can help your colleagues understand what is the difference between something like a chatbot versus ChatGPT. Hi, I'm Dennis, and I'm a chief data scientist with more than 20 years of experience. I'm also a top data science voice on LinkedIn. I want to start on this topic by helping you first understand on what a chatbot is. In these videos, I tend to speak to data science executives and other leaders, so I try to avoid getting too technical. So stay with me for a bit, and I'm going to try to simplify this for you. At core, a chatbot takes in a series of questions matched with their answers as the training data. In essence, what you're saying, here is the answer I want you to display when someone asks this. You can literally think about it as two different columns that you are training your algorithm on. The main portion of the algorithm is looking at the user input, the question, and then it's going to make a decision on which question from your data it knows in its database. You can think of it as a database. If you can successfully match the input from the user with a question, then you can send out the answer that is associated with that question. Now, I know that sounds very close to being like a hard-coded answer, and effectively it is. Again, the algorithm part is in matching the questions, but whatever the answer is the answer that the algorithm sends out. It's essentially hard-coded in that way. I'm putting an emphasis on this because it's an important note, and we're going to come back to this later. So the algorithm that does the input matching to the question is definitely natural language processing, or NLP. In a nutshell, with NLP, we know that words don't really live on their own. Words live in combinations with other words. These combinations of words are known as n-grams. And some of these n-grams are just more likely to happen than others. If you think about the word morning, we know that word morning is very likely to be followed by words like coffee, as in morning coffee, or exercise, as in morning exercise. And it's very unlikely to be followed by a word like guitar, because morning guitar isn't really a combination of words that happens. So if you have two sentences, like the user input into a chatbot and the questions in your training data, and they have enough n-grams that match with each other, you can be reasonably sure that you have a match between what was put in and what your questions are, so you know what the person is asking. Now, in some cases, these chatbots may not even actually be pre-trained models. These are what are known as naive models or runtime models, where all of this processing, all of this math happens as the user is inputting it. There is no pre-trained model that is being used. It's just a series of math formulas that are called when needed. Now, if this doesn't sound very complex to you, that's because it's not, or at least not anymore. Maybe 10 to 15 years ago, if you found some sort of novel approach or a new way to modify the formulas, you could have written a PhD level white paper on this. Nowadays, this whole process I've described to you is more likely to be a capstone project in an advanced data science class at the graduate level. It's really not that complex anymore. In fact, it's so not complex that it's essentially considered a solved problem within data science. There's plenty of vendors out there that can sell you a fairly advanced chatbot that will take in your question and answer sets and give you a chatbot in really a very short amount of time. In fact, it's very likely that your company already has a chatbot deployed that probably works pretty well. So in order to start looking at how generative AI is different than the chatbots that I just described, let's start by taking a look at why ChatGPT is just so captivating. The first reason is that ChatGPT is just so wide-ranging. You can ask almost literally anything and be reasonably sure that you're going to get some sort of an answer back. Everything from travel tips to writing a proper thank you note, and it's going to give you an answer. We've simply never had a tool like that. That tool has really never existed to be that wide-ranging. But hold on a second, that's not really data science. That's not really the function of an algorithm for ChatGPT to be so wide-ranging. It's really the result of sophisticated code and, quite frankly, web scrapers that take in a massive amount of data. We're really just talking about traditional programming tasks, not algorithm development. And then when you add the modern processing power that we have to take in all this data and create these big models, that's really kind of what makes ChatGPT so wide-ranging. But there's really not a lot of groundbreaking stuff here per se. It's really just people, code, time, and money. It's also why many of these AI companies that are currently started are in stealth mode, because there's essentially a race for some of these proprietary data sets that exist within different industries in order to be incorporated into Gen AI models. If you're enjoying this content, please click on like and follow below. So when we're talking about ChatGPT, we're talking about generative AI. Let's hone in on that word, generative, because this is really where things start to get interesting. When you have the time, I want you to go to ChatGPT where you can ask two similar questions. The first question is, can you please explain the rules of the Olympic pole vault? The second question is, can you please explain the rules of the Olympic pole vault in the style of a Taylor Swift song? And you're going to get very good answers for both of these questions. It's quite fun. You should try it. Now, remember how we said in the previous sections that the chatbot answers are basically hard-coded? Well, with the first question we're asked, that's basically a task for a chatbot. A good modern chatbot can answer that. You would have a question that is matched up with the rules of the pole vault, and you can see that the word vault is very likely to come after the word pole. The word pole doesn't really have a lot of words that come after it, so you can easily detect that somebody is asking about the pole vault and the rules. And, well, you get the idea. The solution is there to be able to generate that answer out in a very quick manner. But what about that second part, the Taylor Swift part? And that's really where the power of generative AI is, because it's simply not something that you would hard code as part of your training data. You'd have to hard code for Taylor Swift, you'd have to hard code for Eric Clapton, Adele, so on and so on. You'd have to do every artist under the sun, and that's simply not possible. So instead, the algorithm is smart enough to be able to generate the different answers that you need. It's generating the answer because it's basically not stored anywhere. There is no more database of answers that it calls upon in order to send it back to the users. And that's really where the power of generative AI actually is. It should also be noted that there have been some advancements in how these algorithms take in the user input, take in the user question, and understand the question. But those advancements aren't nearly as interesting as they are on the answer side, the generative side. If you're enjoying this content, please click on like and follow below. I hope this discussion helps you understand why it's important to use wide-ranging documents when you build your own large language model. The more data you give, the better results that can be generated by the model. It's going to be able to generate answers that you wouldn't see on your own by reading the individual documents. It should also help you understand why these models are so resource intensive. There's a lot of data to go through and a lot of connections to make within that data and across different documents. So we've covered a lot in this video. Thanks for hanging in there with me, and I'll see you next time.